All right, well, hello everyone and welcome to part 6 of our Chapter 8 videos, which not only is the last video in our Chapter 8 material, but brings us to the very end of Chem 2100 and our time together on this particular course. And so what we'd like to do here, just as a way to introduce this idea, is we've take a look at all the different organic transformations, organic reactions that we've looked at over the last, especially the last two chapters, 7 and 8, and try and put them together in a way that allows us to start thinking about using them in a way to accomplish kind of functional group interconversions and some synthetic transformations. So we'll take a look at this in terms of this last video and kind of what we want to accomplish here. And this is the one that we said is really kind of predicting the product. We'll do a little bit of that, but more broadly synthesis strategies. And we'll look at a couple of examples in this video about how to do that and sort of see if we can try and put together some of the things that we've been talking about individually over the last couple of weeks together into sort of an overall theme of what to do here. So again, just to go back and take a look at Chapter 7 is a summary of the various different transformations that we talked about, at least in terms primarily of sort of the bimolecular mechanism, primary alkyl halides as substrates, turning them into various other functional groups, including eliminations to make alkenes, substitutions with other different functional groups and other nucleophiles, as well as kind of interconversions like making alcohols into good leaving groups via tosylates and using those to kind of convert back and forth between the various functional groups. We also talked a little bit about tertiary alkyl halides as substrates. Those make actually reasonably good elimination substrates, and we can get both a kinetic and thermodynamic product out of that, or Zaitsev versus Hoffman, as we sometimes call it. And then a little bit of discussion of sometimes that unimolecular mechanism is the only alternative for these particular substrates, and maybe now a little bit with competition between substitution and elimination to give us either an alkene or maybe a substitution product there. We talked about those a little bit. We'll see some examples of how to make use of some of those. And now finally in Chapter 8, here's a summary of all the different addition reactions that we talked about over the last week or so together, sort of additions of HX or hydrohalo reactions, a few other hydration reactions, and a few other dihydroxylations, both syn and anti, and even making bromohydrins, so with bromine or chlorine, and introducing an alcohol group at those positions there. And so what we want to do here is just a couple of brief examples of how to make use of all this information to think about converting one molecule into another, and we'll use this as the basis for our last couple of lectures together to get some examples of this kind of thing. So let me draw up an example of what this might look like here. Maybe we've got a secondary alcohol and we want to convert this into a primary alkyl halide to maybe make it as a substrate for some other thing, or just be able to carry out this synthetic transformation. And so here we've got multiple arrows just to kind of hint that look, several potential synthetic transformation steps might be necessary to capture this out. So what we want to do here for a minute is take a look at this particular reaction in a bit more detail. So in order to do that, why don't we switch over to the iPad here and we'll take a kind of look at these reactions in some more detail. So again, just reproduced here is that transformation that we want to make from that secondary alcohol to that primary alkyl halide. And so if we take a look at it, we think, well, maybe one of the first steps we might consider doing here is transforming that primary or that secondary alcohol into an elimination product, because that might maybe get us a bit closer to the spot that we want to here. So we want to make that potentially that elimination product. Can we carry out this transformation? Well, if we take a look at this particular substrate here, one of the things we can do then is we just imagine what would that substrate would look like, and can we actually carry out that elimination process on this? So if I draw this substrate here and I take a look, one of the things we like to look at is, can we even set this up for an elimination? And if we look at this here, we have to have that OH, the potential leaving group, in an axial position here. There's no anti-periplanar proton on that, anti-periplanar to that OH leaving group to make that elimination product, even if we could make it directly. So we have to do something in order to turn that leaving group into a position that we can get ultimately an elimination product. And so here what we can then imagine doing is first making that OH into a good leaving group. Turn that into a tosylate. And then we can react that with something like sodium bromide in DMSO to convert that from the tosylate into a bromide. And then if we look at it this way here, if I draw out the chair for now, we've inverted the stereochemical configuration at that secondary carbon. And so now I can draw out a chair that kind of shows a little better the fact that now we've accomplished what we needed to do, which is now with that bromine leaving group axial. Now the bromine and the methyl group are on the same side or cis with respect to each other. And now in a position, antiperiplanar, in a position to react in an elimination reaction. So now we can take that bromide as a substrate and we can carry out the elimination to now introduce a double bond. And so we put a double bond at that position. And now the ultimate goal that we wanted to was make the primary alkyl halide. So how can we think about going about doing that? Well, and now that we've got a double bond in place, we can use our reactions that we have. And here we can react this with HBr. To make that tertiary alkyl halide, we put the bromine at that position, again through the mechanism that we discussed in some detail in these addition reactions. And now we can react that with T-butoxide or some other big bulky base that would prefer to give us the kinetic product of this, that is the less substituted double bond. And so now we made the double bond at that position in our six-membered ring. And now ultimately we want to do is put a substituent at the end of that primary carbon, or at the least substituted end of that double bond. And we did want to wind up with a primary alkyl halide, and maybe we don't think of a way to do that directly, and we don't have many ways that would allow us to do that directly, but we might have to do it indirectly. So we do remember having a technique that would allow us to introduce a substituent at the least substituted end of that double bond, hydroboration followed by oxidation with hydrogen peroxide. Makes a primary alcohol at that position. And so now that I've got a primary alcohol, what I really want to do is switch that out to make it a primary alkyl halide. So again here I can use tosyl chloride and pyridine as the solvent to activate that bad leaving group OH into a very good leaving group of a tosylate. Sodium plus, Br minus, so sodium bromide. Not a very strong base, you won't get much competing elimination here, and then ultimately turn that into that primary alkyl halide product that we wanted to when we get started. And so the idea with all of these different steps is to be able to kind of follow a sequence of different transformations using some of the individual organic reactions that we talked about, being able to carry out a transformation to get to a product that we want. We'll take a minute and take a look at another one of these examples before we wrap this up here. So let's look at another example of this kind of transformation. So here we've got a substrate, and again, a series of reactions that we'd want to carry out on this particular substrate to make a product that looks like the one that we've drawn on the right side here. And again, the multiple arrows just suggest to us that there's several different transformations that we need to make. And so we see here that we start with something that's got a double bond and an alcohol all in the same molecule, and we form a cyclic ring as a result of this. So we've got to do something to the double bond that would make it turn into something that would be activated to close that ring to make that cyclization. So one of the reactions I could think of doing here would be adding some bromine to make the bromonium ion. So we make that cyclic bromonium ion, and now that intermediate gets captured or reacts with that alcohol that forms part of that chemical structure. Again, at the more substituted end of that bromonium ion, this is the step and we do have a little bit of water as a solvent here, and that would capture that proton, remove that proton, to give us now the cyclized product. And now we've formed what's a great SN2 substrate that is that primary alkyl halide. And so to displace that bromide to the cyanide, we just carry that out under good SN2 type conditions. Again, cyanide's a moderate nucleophile and is really good for doing this kind of reaction where we displace that bromide with the cyanide and ultimately getting to the final product that we wanted to get to in this particular step. And so again, just a couple of examples to kind of get us thinking about this general direction. We'll do a few more examples of this kind of stuff in class as we kind of work through the last of our bit of our time together. And again, so just as a way to kind of wrap up everything here, that's really it for us. We've hit the end of Chem 2100. This is the last of the videos that we'll post with new content in it, and just wanted to kind of get an idea to kind of put everything together. And we've kind of covered a lot of ground, especially the last couple of lectures and the last couple of weeks together. So we'll try and spend some time the last couple of lectures trying to put it all together. So for now, I'm going to stop the last of the videos there and say everyone thanks a lot for following along with all of these videos, and we'll see you all in class the last couple of days.